Welcome to BFR Radio, a podcast dedicated to all things blood flow restriction training. This podcast is proudly sponsored by the BFR.co, where if you want to buy your own BFR cuffs, access online BFR training programs, increase your own BFR knowledge with the accredited BFR.co course, or you want more information about this type of training, this is your one place to go. And I'm your host, Dr. Chris Gavilio. Welcome back to BFR Radio. Hope you're doing well. This episode is part of a short series on how BFR training can help with cognitive function. Or in other words, can BFR training improve the function of our brain? In our first episode, we touched on the importance of exercise in general and cognitive function. We also discussed a few key terms or markers that are associated with improved brain function. Our second episode then looked at how we can use BFR resistance training to assist with improved cognitive or brain function. Although this was a hypothesis paper, it looked at the reasons why the addition of using a BFR cuff to resistance training could provide a more effective method than just resistance training alone. This focused on the activation of hormones and molecular pathways that are associated with the localized hypoxic environment created by the BFR cuffs. Hypoxic being low oxygen. This episode, or rather the article review, also covered the variables that are important in BFR use, such as cuff width, inflation pressure, cuff material, sets, reps, rests, and loading. Hopefully this was a really nice refresher for you. Today's episode is going to look at a study that investigated the effects of BFR walking on cognitive function. Quickly, before I get into this, two other things that I want to cover. The first is in the first two episodes, I had an additional segment called What Would You Do? The first answer I put on my website, would you prefer this rather as a short podcast release? I've actually recorded the second one verbally. I haven't released it. Not quite sure what to do there. And to be honest, what's easier for me is to release it as a short audio podcast that next week. If you are enjoying it or you do enjoy this type of little segment and an audio podcast release is just as easy for you, somehow let me know. That'd be really appreciated. And I'll make sure I keep that process going for you. And the second thing is that if you've been listening, you would notice that I released another segment called Questions in Cars. This is where I answer one of your own questions related to BFR use. And I found that the questions I get time to time are a little difficult to answer in a few sentences. Therefore, I decided to try recording my answer. And to be honest, once again, it's a lot easier for me. And I'm able to get a more thorough answer out for you. And releasing these episodes is also a great way for everyone to continually learn as well. So two things with this. One, if you did hear it, that's the questions in cars. Did you like it? And secondly, if you have a question you want answered, direct message me or email me at chris@thebfr.co with your question. I'll post the answer as quickly as I can on our BFR.co Facebook page. This will be an early release for those people who have joined that Facebook group. For everyone else, I'll then be scheduling these on whichever audio podcast platform you're listening to, and I'll schedule them according to the series and what I'm looking at as well. Back to today's article review, and we are looking at an article called Blood Flow Restriction Improves Executive Function After Walking. As this article looks at the role of aerobic exercise, the intensity and duration of exercise tends to be a major influence on how much executive function or brain function improves as a result of exercise. However, due to the deteriorating condition of the cardiovascular and musculoskeletal systems in older people and patients with chronic diseases, high intensity or long duration exercises are frequently challenging. Furthermore, from a more simplistic perspective, it is thought that one of the barriers to exercise participation is the necessary increases in intensity, in exercise intensity and duration. Therefore, the ability to provide an exercise option that is low in intensity and brief in duration, which can improve executive function or brain function, is really helpful for increasing the applicability of exercise and exercise adherence, in particular in this population group. As I've covered in previous podcast article reviews, this is where the addition of BFR provides a fantastic option to improve the physical response to low intensity exercise. BFR walking studies have shown to improve some physical functions, including aerobic capacity, and some of these positive responses are thought to be a result of improving hormonal responses and activating muscle protein signaling. That's muscle protein signaling that will enable our muscles to get bigger and stronger. Numerous studies have examined how BFR exercise affects cerebral activation. And since lactate is an essential energy substrate in the human brain, it has been found that BFR aerobic exercise increases the cerebral uptake in lactate levels. As a result, BFR exercise can improve cerebral lactate metabolism. As there is a link between executive or brain function and accelerated cerebral lactate metabolism, possibly through elevated blood lactate levels, it was proposed by the authors of this study that increases in blood lactate levels is the reason why BFR exercise enhances post-exercise brain function. And therefore, this study looked at how BFR walking affected post-exercise brain function gains to test this theory. Now, in the methods, there was actually two studies done here. The first study, the participants sat down for 15 minutes, whereas in the second study, exercise was programmed at 5 sets of 2 minutes walking at 5 kilometers per hour with 1 minute rest intervals for a total of 15 minutes. Therefore, you're looking at the addition of BFR doing nothing versus doing low intensity exercise. Remember, it's 5 kilometers per hour, pretty slow. Therefore, fits nicely in this low intensity type of realm. To understand any changes or improvements in cognitive function, they used a few different tests of which we've covered in previous podcasts. And once again, I'm just going to refresh your memory, so no need to worry here. The main test of cognitive function was the color word Stroop task. This is a classical psychological experiment that measures the ability to selectively attend to a particular stimulus while inhibiting the processing of another stimuli. In this task, individuals are presented with a list of color words like red, blue, and green, but the color of the ink used to spell the word does not match the word itself. The task is to ignore the word and instead name the color of the ink used. This creates a conflict between the automatic processing of the meaning of the word and the effortful processing of the color of the ink. This conflict causes the task to be more difficult as individuals must inhibit the dominant response, which is to read the word, and instead focus on the color of the ink. The time it takes to complete this task is used to measure cognitive control, attention control, and interference control in the brain. For this study specifically, the stimulus words were 4 color names: red, yellow, green, and blue. They performed 3 types of the color word Stroop test, 2 color text tasks, which was a congruent and incongruent task, and 1 control black text task, which was referred to as a neutral task. That is, the color was black and the word was black. Now, a congruent task, this is where the color of the word and the word itself is exactly the same. For example, the word red is printed in red color, blue in blue color, and so on. In these tasks, the color and the words are matching, which typically results in faster response times and fewer errors. This is because the brain processes the color and the word as a unified piece of information, leading to less cognitive interference. In contrast, the incongruent task, the color of the word and the word itself don't match. For instance, the word red might be printed in a blue color. Green might be printed in a yellow color, and so forth. And as we could imagine, these tasks create a conflict between the color that's printed in and the word itself, requiring more cognitive effort to process. As a result, response times are usually slower and the rate of errors are higher. This happens because the brain has to suppress the automatic tendency to read the word and instead focus on the color of the text. During the color word Stroop test, they took a few additional measures and calculations. The first is that they measured arousal experience and they used a 6-point felt arousal scale, an FAS. In the case of the colour word Stroop task, FAS was used to measure the level of arousal that the participants experienced while attempting to name the colour of the ink in which the word was printed, rather than reading the word itself. A self-report measure, participants asked them to rate their level of arousal on a 6-point scale ranging from very calm to very aroused. The scores provided information about the psychological state of the participants during the task and could be used to understand how the brain processes and inhibits conflicting information. Overall, the use of the FAS can aid in understanding the cognitive processes involved in complex tasks like the Stroop task. Incongruent reaction time was another measure. With respect to the Stroop test, this is the measure of the time it takes for the person to identify the colour of the word when the colour and the word itself don't match. The incongruent reaction time is typically longer than the congruent reaction time, where the word and the colour match, and the participants must overcome the automatic response of reading the word or instead of identifying the colour. This delay is thought to indicate a higher level of cognitive processing, specifically the ability to inhibit automatic responses and selectively attend to relevant stimuli. The reverse Stroop interference score was also calculated. This is a specific parameter of inhibitory control and is defined as the difference between reaction times of the neutral and incongruent tasks, with high scores indicating better inhibitory control. Other measures around the performance of the Stroop test included understanding mental fatigue, the ability to focus, and motivation using a visual analog scale rating. The measure varied between not at all to extremely on the scale. The physiological measures taken included heart rate, blood pressure, and a 15-point Borg rate of perceived exertion to assess not only exertion in total, but also leg discomfort during the walking, and also they measured blood metabolites of blood glucose and lactate levels. Remembering earlier we were talking about the importance of blood lactate in brain function. If we look at the methods on the experimental day, the participants performed the colour word Stroop test, and the results from this test was used as the pre-intervention measurement. After that, the participants were exposed to either the BFR or the non-BFR session, and the participants then performed the colour word Stroop test immediately after the completion of the session. If we look at the BFR conditions, they used lower body cuffs, and to get the subjects used to the BFR, the occlusion pressure was first pumped up to 100 millimeters of mercury for 30 seconds, decreased for 10 while they were sitting down, and then it was slowly raised in increments of 25 mils of mercury. And this was getting them used to this pressure until they reached 200 millimeters of mercury. So prior to the BFR session, the cuffs were then pumped up to 200 mils of mercury, and in the walking study, the BFR pressure stayed the same until the end of the experiment. So it was a continuous pressure. And then remembering in study 2, the exercise was set up to be 5 sets of 2 minutes of walking at 5 kilometers per hour with 1 minute of rest between each set, a total of 15 minutes. For the results of this study, I just really want to focus mainly on study number 2, as I'm looking at the role of BFR low intensity exercise on brain function. But just quickly, for those interested in study 1 results, there was no significant interaction effects for the addition of BFR. In other words, if you're going to sit with BFR, there's going to be no significant improvements in brain or cognitive function. For the results in study 2, when they were walking, RP and leg discomfort whilst walking was higher with BFR than with non-BFR, with large effect sizes for both. This is pretty much what we would expect would happen, is if you're going to add BFR cuffs, even at a low intensity, that the rate of perceived exertion or how hard it feels and the leg discomfort due to the inflation of the cuffs, it's going to be a little bit higher than if you had no cuffs on at all. But remembering it is the stimulus of the cuff that tends to be giving us these really great effects with low intensity exercise. If we look at heart rate analysis, it went up right away for both the blood flow restriction and the non-BFR walking group compared to what it was before walking, and the effects were quite large. With the addition of the BFR, the heart rate was higher whilst walking compared to the other group which had no BFR cuffs on. Blood lactate analysis. Now, this is a really important one. Remember, we mentioned earlier about the importance of lactate in the brain, and it showed that compared to pre-walking values, blood lactate was higher after BFR walking, but not after the non-BFR walking group. And this was significant and had a large effect size. Blood glucose analysis revealed no significant effects for either group. If we get into the cognitive function parameters before and after the walking sessions, showed that after BFR walking, the incongruent reaction time decreased, but not after the non-BFR walking. Remembering that the incongruent reaction time is a measure of the time it takes for a person to identify the color of a word when the color and the word itself do not match. The incongruent reaction time is typically longer than the congruent reaction time. That's when the color and the word are the same. And therefore, if we could decrease this, this is an advantage. When the reaction times for the congruent and the neutral tasks were analysed, there was no major significant finding here. BFR walking also improved the reverse Stroop inference test, and like the other results, the non-BFR walking didn't improve this score at all. Remembering again that the reverse Stroop inference test is defined as the difference between reaction times of the neutral and the incongruent tasks. And after the walking, the BFR increased arousal more than not wearing the cuffs at all. Mental fatigue was also found to be higher after BFR walking than non-BFR walking. And when the ability to focus and motivation was looked at, there was no significant interactions. In summary, study 1, which we didn't really focus on, highlighted that using BFR alone whilst at rest does not improve cognitive function. However, the addition of walking whilst wearing the BFR cuff does. The improvement in cognitive function was highlighted by a decrease in the Stroop inference score, and no positive effects were observed for the non-BFR walking group, showing that the addition of the BFR cuffs is needed to improve cognitive function. The improvement in inhibitory control as reflected by a decrease in the reverse Stroop inference test as a result of wearing BFR cuffs while walking was 59%. When you look at other studies investigating the effect of non-BFR exercise training and cognitive function, cardiovascular-based exercise of high intensities and longer durations are typically needed. For example, high-intensity interval exercise, this is non-BFR high-intensity exercise, with a 33-minute duration, that's double the amount, has been reported to improve inhibitory control by 52%. That's similar to what we saw in this study at 59%. And also for moderate intensity continuous exercise of a 40-minute duration, they showed an improvement of 51%. So we can see here that you need to be exercising for over double the amount of time if you're not wearing the cuffs at a moderate to a higher intensity. Although we are focusing on aerobic exercise, looking at non-BFR resistance training studies, the results from BFR walking is the same as that for high-intensity resistance exercise of a 17-minute duration, and was about 1.8 times higher than that for low-intensity resistance exercise with that 17-minute duration. So even though BFR walking is a light exercise, it can quickly and effectively improve cognitive function, especially inhibitory control, in a way that is similar to other protocols of aerobic and resistance exercises, but these are of a more intense and a long duration. So what's at play here? From a mechanism point of view, blood lactate potentially is the major player. During exercise, the brain turns to systemic, that's the systemic lactate, that's the lactate in our body, as an important source of energy to replace glucose. The degree to which aerobic exercise improves executive function is linked to blood lactate levels. And as this study showed, blood lactate levels were not changed by BFR alone or by walking alone, but they were increased by BFR walking. Other studies have also found that cerebral lactate metabolism was higher right after low-intensity aerobic exercise with BFR than it was before. So the possible effect of BFR exercise on improved cognitive function after exercise may be due to increases in lactate levels in the blood and lactate metabolism in the brain. There may also be other factors involved in how BFR walking improves executive function after exercise. It has been shown that an increase in arousal caused by aerobic exercise is linked to an improvement in executive function and neural activity in the brain after exercise. Their results suggest that changes in perceptual responses like arousal caused by exercise may actually help improve executive function. Even though BFR alone did not change arousal as it was measured by the felt arousal scale, arousal was higher after BFR walking. Also, it has been reported the BFR group felt more awake after walking than the non-BFR walking group. The authors postulated that the combination of BFR and exercise may lead to an increase in both the hypoxic and metabolic responses of the exercising muscles. Briefly discussing the pressures used during the BFR cuff walking, they used an absolute pressure of 200 mils of mercury. The study didn't appear to use an individualized approach, and hence this is why the RP and leg pain was higher in the BFR group compared to the non-BFR group. But to be honest, as I alluded to earlier, I would have expected this to be the case anyway. However, it would have been interesting to see if an individualized approach may have led to a different cuff pressure, may have also led to a slight modification of RPE scores. Interestingly, I couldn't find the width of the cuff or the brand used. However, using my powers of deduction, as the paper came from Japan, we could suggest that they used a narrow cuff and used the Katsu type brand. And typically, a narrow cuff requires a higher training pressure when compared to wider cuffs. Therefore, potentially a modification could be to use a wider cuff. Also, personalization of the cuff pressure may also have revealed a lower pressure could still be used with the same positive effect in improved cognitive function. That, however, is another study. Other points to note is that in the study, they chose young, healthy men for the study. Effective exercise programs to improve executive function are more important for older people and people with long-term illnesses. Therefore, we need to look at studies with this type of population. Irrespective, this type of training shows great promise. And based on that last point, the next episode will actually look at a more relevant population BFR study. And that's all for this episode. To keep the content fresh, I will be interspersing my questions and cars segment, so stay on the lookout for that. And again, if you do have a burning question about how to use BFR, contact me and I'll spend some time giving you a thorough answer. If this episode has sparked your own interest in starting an exercise regime, get in touch with me through my website, thebfr.co, or socials, which is at thebfr.co, or if you're on Twitter or X, it's at the BFR_co. You can also purchase your own BFR cuffs from our website and also contact me there as well. And you can find it at www.thebfr.co. And lastly, before I go, a couple of favors from me to you. If you know of someone who would benefit from this episode, please share it. And if you are enjoying the podcast, please give it a ratings on iTunes. Thanks for listening, and remember to keep the pump.